So the first question in this formative, we're given this function g of x, and they want us to find g prime of x. I'm going to rewrite this function as ln x times x to the negative 2, because I don't want to use the quotient rule because I'm lazy. So let's take the derivative of the first function, 1 over x, multiplied by the entirety of the second function, plus the entirety of the first function multiplied by the derivative of the second function, negative 2x to the negative 3. Okay, so this will be 1 over x cubed, because these two multiply, and this is x to the negative 1, meaning these exponents will add. And then we're going to have plus ln x times negative 2 divided by x cubed. So altogether we'll get that 1 minus 2 ln x over x cubed is the derivative of this function. So the second part of the question asks that for the maximum point of a x value, where g prime of x has a maximum point of a, and the question just wants to know the x value. So we can find this out pretty easily by setting the entire function above to equal to 0. So 1 minus 2 ln x divided by x cubed is equal to 0. Anything over anything, as long as the numerator is 0, divided by anything will be equal to 0, so we don't need this x cubed part. 1 minus 2 ln x is equal to 0. That means negative 2 ln x is equal to negative 1. These will cancel out. Ln of x is equal to 1 over 2. And of course this means that x is equal to e to the 1/2, or square root e. So the second question here wants us to find the equation of t when given this function 2x squared. So t is a tangent line at this point where x equals 1. So we're going to find the derivative of the initial function in order to find the slope of t here. So f prime of x should be simple to find with the power rule for x. Plugging in the point at 1, we'll get that the slope should be equal to 4 times 1, which is going to be 4. So we know that the slope, or m, of t, since we know it's a linear line, which means the power of x is 1, we know that the slope must be 4. So what can we do with 1 point and the slope? We can use this here, which is the point slope form, minus x1. So we're going to evaluate and find this point first. So that point is going to be, the x value is obviously going to be 1. Then what will the y value be? It'll be 2 times 1 squared, which is just 2. Y equals 2 at this point here. So y minus 2 is equivalent to 4 times x minus 1. Little bit of expanding, we'll get that y is equal to 4x minus 4 plus 2. And the final equation of t, y equals 4x minus 2. Now to find the x-intercept of t, since we have the formula for t, it's simple. We're going to set the y to 0, since that means it'll be touching the x-axis. Minus 2, that means 2 is equal to 4x. 2 over 4, or 1/2, is equal to x. And that's our answer. The third question shows us a graph like this, and it is not specified what the actual function of this graph is. We just know it's f. And it wants us to find the x-intercepts of f prime. So the x-intercepts would be when the function is flat. That means there is no increase, meaning the y value of the derivative function is 0. So the points where there's no negative or positive increase are at negative 3, 0, and at 2. So you'll have the points negative 3, 0, 2. And those are your answers for the x-intercepts. Since we can see here that this is an increasing function on the both sides here, and that this is only a local area. And the next part asks for what x is f prime of x positive. So since we're talking about the derivative function here, it's only the parts where there's an increase. So here there's an increase and it steadies out here, but it's still increasing to a point before decreasing. So we can see that from -3 to 0, there's this behavior, and then from 2 onwards. So from -3 is less than, or not equal to, because at that point the slope is 0, x, 0, and then for x is greater than 2. Yep, because it's an increase here, and it's an increase here. So for the fourth question here, we're just going to use the product rule. Derivative of 2x, this is 2, multiplied by sine x, plus 2x times the derivative of sine x, just cosine x. And then I'm going to factor out 2. We get that 2 times sine x plus x cosine x is our derivative function. And the question asks us to find what g prime of pi will be. So let's plug in pi into all of these values. So we'll get that 2 sine pi plus pi times cosine pi is what we need to evaluate. So if we look at this graph here, pi is 180 degrees, so we'll be going all the way here back to the x-axis. You can imagine we have a flat triangle here with 0 height, a radius of 1, and a x value of -1. So sine pi is going to be opposite over hypotenuse, 0 over 1. Cosine pi is going to be -1 over 1, which is -1. So we'll get that 2 times 0 plus pi times -1 is our answer. We'll get that 2 times -pi, which is just -2 pi. The fifth question gives us an equation to model the number of bacteria in a dish, n, after t minutes with this equation here. You can call this n of t, just for simplicity. The first part asks us to find the value of n when t equals 0, so n of 0. So we're just going to plug in 0 for t here, so we'll get that n will be equal to 800 times e, 13 times 0 is just 0. This is 1, 800 times 1. Look, the n should be 800. You can verify this with the graphing calculator. So n prime of 15 is the next part of the question, because it asks find the rate at which n is increasing when t is equivalent to 15. So what we're going to have to do is find the derivative first. So our function is 800 e to the 13. So let's take the derivative. The derivative will be 800 times e to the 13t multiplied by the chain rule of this, which is just 13. We're going to have to do 13 times 800, which is going to be quite a big number, but let's try. 3 times 800, 2400. 10 times 800, this is going to be 8000. And this should be 10,400. So we'll get that 10,400 e to the 13. T is going to be our derivative here. And then we'll have to plug in 15 and find the rate at that value. 10,400 times e to the 13 times 15. 13 times 15, not something I know off the top of my head. 5 times 13 would be 50 plus 15, so 65. And 10 times 13, 130. We'll get 195. Sorry for the messy board here today. 10,400 e to the 195 will be our answer. So the sixth question, finding the derivative of this function is not the hard part, but rather just a little bit of the wording of the question, which asks us to find the gradient of the normal to the curve at x equals pi for f of x, which is this. So you might not immediately know what the normal to the curve means, but if this here is a tangent to a curve we have, then the normal will be the perpendicular line across this tangent. And to find this, when we know the slope of the tangent, if we want to find the perpendicular one, which people usually mark with this upside down t looking thing, we do 1 over m, and it'll be negative, so the negative reciprocal. So let's first start off by finding the derivative. Our function was e to the x times cosine x. Product rule here, so f prime of x is going to be e to the x times cosine x plus e to the x times negative sine x, or you can factor out the e to the x, cosine x minus sine x. Alright, so now we would have to plug in for x equals pi to find the slope. Look at that, e to the pi, cosine pi, we found earlier, 1 minus, negative 1 minus 0. We get that this should be negative e to the pi. And so we know that this is the slope at that point for the tangent line. So for the normal, we'll have to be the negative reciprocal of this. 1 over negative e to the pi, which will just be 1 over e to the pi, or e to the negative pi. So I hope that helps with your understanding of this formative test. The final two questions, 7a and 7b, I covered in the previous video, finding the derivative of those two functions, and one of them happened to be a typo, and I found the derivative anyway. So please ask in the comments if you have anything.